Welcome to Say on Busy Made It Easy channel, the only channel exam fears in Ghana. Today we are going to have a lesson on two-set problem, purposely our complement. Some students asked that I should have a lesson or I should have a video on complement. So today that's what we are going to do. Now to find the complement of a set, it means you are comparing the universal set to other sets. Now, with example, let's say in the universal set U, you have 2, 3, 4, 5, 6, and 7. And you have been given set A as 0, 1, 2, 4. And the question is asking you to find a complement. Now, a complement simply means that what numbers are in the universal set that are not in A? That is simple as that. What numbers are in the universal set that are not in A? So now when I compare these two sets, now there is 3 here, there's no 3 here. So you write it 3. Now there is 5, there's no 5 in A. There is 6, there's no 6 in A. So when they say find a complement, basically this is how we find a complement. So we all know universal is the mother of all sets. Yes. So complement means numbers in the universal that are not in the given set you are talking about. So that is simply what complement is about. So let's quickly take a full question on this complement. So as the question is posted on the screen, given that set U is 1, 2, 3, dash 12, M is equal to prime numbers and N is odd numbers greater than 5. A says if M and N are subsets of the universal set U, list the element of U, M, N, M complement and N complement. Now, they've given you the universal set which is not complete. So always when you see a question like that, make sure you complete the universal set. And M and N are subsets of the universal means that when you list the M and N, they should all be found in the universal set. That is the meaning. So because the person has asked us to find the element or to list the element of U, you have to complete the universal set. So U, the set is 1, 2, 3, dash, and they gave us the last number as 12. So you list 1 to 12. So we have 5, 6, 7, 8, 9, 10, 11, and 12. So this is the universal set. And they are saying M is prime numbers. If you don't know what a prime number is, you can't list it. Prime numbers are numbers with only 2 factors. And the first prime number we know is 2. The factors of 2 is 1 and 2 is so 2 is prime number, 3 is prime number, 5 is prime number, now 7 is prime number, then 11 is also a prime number, and I think that is all. Now many people think that all odd numbers are prime numbers. No, 9 is an odd number, but it's not a prime number. The factors of 9 is 1, 3, and 9. So it's what? It's a composite number. So take note of that. And the only prime even number is 2. It is even number and a prime number. So these are the prime numbers in the universal set. And set N. Set N is also odd numbers greater than 5. Numbers that are not divisible by 2. So odd numbers that when 2 divide, there will be a remainder. They are not divisible by 2. That is odd number, and they are saying that they are odd numbers greater than 5. So the first odd number that is greater than 5, we say 7, followed by 9, then we have 11. So these are the odd numbers greater than 5 according to the universal set. Yes, according to the universal set. I find the universal set M and set N. Now we have to find M complement. M complement. So M complement means you are going to compare the universal to set N. What numbers are in the universal that are not in N? So we can have 1, we can have 4, we can have 6, we can have 8, we can have 9, we can have, so we can have 1, 4, 6, 8, 9, 10. Then finally we have 12. M complement. These are the numbers in the universal set that are not found in set M. So let's now look at N complement. Numbers in the universal that are not in N. So we have 1, 2, 3, 4, 5, 6, 8, 10. Then we also have 12. This is n complement. So this is what we have listed. Now B says that the BI says we should find m complement intersection n complement. So we are going to compare m complement and n complement. Intersection means common numbers. So this is m complement, this is n complement. What are the common numbers that are in n complement, that are also in n complement? So when we look through, we can see that we have 4. No, from the lowest. So we have 1. 1 is common. 4 is also common. Now 6 is common. Then we can have 8. 8 is common. 10 is common. Then 12 is common. So this is m complement intersection n. So this is the II. This is the I. The II says that we should find m complement union n complement. Union means putting the two sets together by listing the numbers in either descending or ascending order. So now from the lowest, we can have 1, 2, 3, 4, 5, 6. We don't have 7. So we have 8, we have 9, we have 10, then we have 12. This is m union n complement. Yes, that is it. So we have III, which says that we should find m intersection n complement. This one we're going to find the intersection of set m and the n complement. So these two sets, that's what we are going to find their intersection. So now let's compare set m with n complement. Any common number. So we have 2. We have 2 here, 2 here. We have 3, 3. We have 3. We have 5. 5 is also common. Now 7 here, there's no 7. 8, there's no 8. 10, there's no 10. 12, there's no 12. So this is the m intersection n complement. So I person say we have to represent m, n, and u on a Venn diagram. So we are going to represent it on a Venn diagram. So the union, so we have set m, then set n. Now before you draw the Venn diagram for them to intersect. Now it's not all Venn diagrams that intersect. There are some you can have a separate circles. But this one, before you draw them to intersect, check if there is a common numbers in the m and the n. This is what you have to check. If there's a common number in the m and the n, then meaning you can intersect the circles. So this one, we have a common number in the m and the n, which is 11. So we can intersect the circles. Now, always list the common numbers first. So this one is m only. So the common ones we can have 7 and 11. So you list that one first in this intersection. This is the intersection. So 7, then 11. Now when you come to set m, you list the others apart from 7 and 11 because this one is here already. And set m covers here. So we can have that one 2, 3, then 5. Including this one, complete is 7 and 11. Now when you come to set n, we have 7 and 11. So the one left is what? It's 9. The one left is 9. Now their union. The union entails 1 to 12. So now you look at the numbers here and compare it to the union. What are the numbers left? Now when you leave them outside the circle. So now 1 is left. Now 2 is here, 3 is here, 4 is not here, so you list 4. 5 is here. So we have 6, 7 is here. So we go to 8, 9 is here, we go to 10, 11 is here, then we go to 12. So union. The union means that all the numbers. So this entails all the numbers. And this one is set m, it covers here, then set n covers here. So this is simply what is meant by complement of a set. Complement, compare the universal to the set they are talking about. Then you list them out. So this is the end of today's session. Follow for more. Don't forget to subscribe to Sir Young Busy Minute Easy channel.